In all the sense of the word, an engine is basically an air pump. An air pump that requires timing, and without the proper timing, the engine refuses to work. And what makes that timing? The camshaft in connection with the distributor and the crank. But the camshaft is the most important part. Without a camshaft, your engine doesn't run. In this video, I will go through the introduction to a multi-part series about camshaft tech. So, can you tell the difference between these two camshafts? This is out of a 4AC, and this is out of a GM V6. This one's overhead valve, this one's overhead cam. And the easiest way to tell the difference is the wear pattern. If you look at the wear pattern on this one, the wear is only on the top of the lobes. Whereas a camshaft that's overhead valve, that has lifters, it has wear all the way around. Its main spot of wear is on the tip of the lobe, but it has wear all the way around. This is hydraulic roller, which means a hydraulic roller lifter rides on it and pushes a push rod onto the rocker arm and opens the valve. That's what overhead valve means. Overhead cam, well, most cars have lifters in them. The oddities happens to be a 4AC. It has absolutely no lifters on it at all. All it is the lobe pushes the rocker arm, which pushes the valve open, which is why the wear pattern is only on the lobe. Timing is everything. And when I mean that, a camshaft is required to know when to open and close the valves. And also know how long to hold the valves open, which is what the lobes are for. Now, performance camshafts were taken to a next level. Stock camshafts do their thing. And we're not talking about variable valve timing. We're going to get into that into another video. The performance cam started during the hot rod era. We can all thank a man named Ed Iskandarian. He's the guy who first created the performance camshaft. And Isky camshafts are still around today. But after him, a lot of companies started coming out with their own, like Comcams for 4ACs, which do regrinds. And what regrinds are is you take this in, which is a used one, and they regrind it to their specs and turn basically a stocky into a performance cam. That would be Schneider racing cams. And here's the distributor gear, and if you can see here, here's an eccentric ring that's on an odd shape, and it has a wear pattern on it. This is where our fuel pump works. The fuel pump arm rides on here, and when it rotates, it goes up and down, making the fuel pump work. I don't have the cam gear for this one, but I do have the cam gear for this camshaft. Here's your typical cam gear, at least for the 4AC. It has a notch. It also has a little point here. When you put the engine together, they all have to go together. You match the points up, so when you build it stock, and you set the engine to top dead center on the first cylinder. And we'll talk about upgraded versions of these in another video. We're just doing introductions here, and little information tidbits. For a GM or any overhead valve engine, usually there are bearings that are on here. And here's another oddity of the 4AC. The 4AC camshaft doesn't have bearings, which I will show in a later video. This just rides in an oil valley. That's it. And you can see it's not that very much wear on this. This camshaft came out of an AE82 Chevy Nova. And funny, huh? With only 68,000 original miles. This is where the distributor gear would go. And this one is where the cam gear would go. That. Camshafts are considered a complicated item because there's a lot of terms in it that are very hard to explain. The next video we're going to go in depth on those terms and what they mean. This is 84 Hot Tree signing off.